Hello to everyone. In this video, let us discuss nomenclature of complex compounds. So, how to name a complex compound? Let us see here. For example, consider this K4FeCN taken 6. With this example, we have to learn how to name a complex compound. So, the first thing is here to name a complex compound, a simple rule we have to follow. We have to name that complex compound from left to right. Of course, we may say that first we have to name the cation, then coordination pair, then after this coordination pair, sometimes anion also present. That means we have to follow that order. Left to right, we have to name a complex compound. That means here first we have to name the potassium, then this coordination pair. That means from left to right. And the second important thing is here, no need to use di, tri, tetra. No need of these. For which one? The species present outside the coordination sphere. That means for the species present in ionization sphere, no need to use di, tri, tetra, etc. That means here we have to pronounce this as just potassium. No need to say tetra potassium. So I will write this name here, potassium. We have to name it. Okay, then after naming this ionization sphere, we have to enter into coordination sphere. In the coordination sphere, first we have to name the ligands. In coordination sphere, we have to name first which one? Name the ligands. We have to name which one means here ligands. So here which ligand is there? Cyanide. Already we know that in naming that anionic ligands, we have to use suffix O. So it is named as cyano. And if more than one ligand is present, that number should be indicated as di if two ligands are present. If same ligands two are present, we have to use di. If same ligands three are present, we have to use three, try, that is. If same ligands four are there, we have to use tetra, like that. If five same ligands are there, penta. If six same ligands are there, means hexa. We have to pronounce like that, di, tri, tetra, like this. So here six cyanide ligands are there. That means we have to name it as which one? Potassium hexacyano. Potassium hexacyano. After naming the ligands, we have to name the central metal ion. While naming the central metal ion, one thing we have to remember. If it is anionic complex, the central metal ion name should be in Latin language. That means if iron is the central metal ion or atom, it is named as which one? Ferrate. If Sn is the central metal ion, it is named as stannate. If copper is there, cuprate. If nickel is present, nickelate. So in case of anionic complexes, central metal ion should be named in Latin language. So it is anionic complex only. So now we have to name it as which one? Ferrate. And after naming the central metal ion, we have to write the oxidation number of that central metal. Now here, 4 potassiums and 6 cyanide ions are present. That means oxidation number of iron is how much? -6 and +4 means -2. X minus 2 equal to 0. That means we can write like this here. 4 plus x minus 6 equal to 0, we can get x equal to +2. So we have to write that oxidation number in parentheses, that too in Roman number. So now this is the name, potassium hexacyanoferrate 2. Okay, now like this we have to give the name. And let us see one neutral complex compound and one cationic complex compound also. So one example for neutral, NiCO taken 4. Here no cation is present, no anion is present. This is a neutral complex compound. First we have to name this ligand. This is carbonyl. As 4 carbonyl ligands are present, it is named as tetracarbonyl and it is nickel and oxidation number 0. So now this name is tetracarbonyl nickel 0. Now let us go for which one? One type of which one? Cationic ligand or cationic complex compound. So see what is that example here. CrNH3 taken 6Cl3. Here 6 amine ligands are present. So it is named as hexaamine and it is chromium, but no need to write its Latin name, just we have to write it as chromium. No need to write that chromate. No need to write chromate, just we have to write chromium. Immediately we have to write the oxidation number. Chromium, let it be the X, and ammonia oxidation number 0, 6 into 0 plus 3 into each chlorine minus 1 equal to 0. So oxidation number we can get to plus 3. So we have to write Roman number 3, and outside this coordination sphere chloride ion is there. So we have to name it as chloride. No need to write trichloride. Already we given that hint. Outside the square bracket, no need to indicate di, tri, tetra, etc. No need to use them. So what is this name? Hexaamine chromium 3 chloride. So these are the three types of which one? Anionic, neutral and cationic. And another one here, if more than one type of ligand is present. Up to now what we have taken examples, only one type of ligand, but more than one those are given. But now let us go for which one? If more than one type of ligands are present, those ligands should be named in alphabetical order of their names, not the symbols. So see here one example I give here. What is that example? So CrNH3 taken 5Cl outside the square bracket. That means coordination sphere, 2 chloride ions are there. Now how to name these? First, here NH3 group means its name is amine. That means start with A, amine. And chloro means that name start with C. As per alphabetical order, amine A comes first. So we have to name first amine, then only we have to name the chloro. So now what is its name? As 5 amine ligands are there, pentamine and chloro, and this is named as chromium. Now we have to write its oxidation number, and chromium we have to calculate. So X for ammonia 0, 5 into 0, 1 plus 2, 3 chloride ions. Total 3 chloride ions means 3 into minus 1. Net charge is 0. So equal to 0. So we can get X equal to plus 3. So we have to write 3. And here after that what is there in this ionization sphere means chloride ion. So we have to write chloride. So its name is what here? Pentamine chloro chromium 3 chloride. So like that, if more than one type of ligands are present, we have to name them as per alphabetical order. Okay, after this, sometimes they may give charge on coordination sphere. If charge is given, what is the change we have to do here? See, for example, FeCN taken 6 minus 4 they have given. So this is anionic complex because minus charge is there. So now first we have to name the ligand as 6 ligands here. What is its name? We have to give hexacyano. As it is anionic complex, Latin name we have to use ferrate. And oxidation number let us calculate here. So for iron we have to calculate, so X plus 6 cyanides means minus 6 equal to, now charge is there, minus 4. So we can get the oxidation number plus 2. So write that in that parenthesis. So now hexacyanoferrate 2, but it should be concluded with ion because that is not neutral they have given. Minus 4 is given means we have to conclude the name with ion. So this is naming for which one? If charge is given for such type of complex compounds. And then if sometimes the complex ligands may be present. Complex ligands are which one? Ethylene diamine, glycinato, such type of ligands. So to indicate the number of such type of complex ligands, instead of di, tri, tetra, etc., we have to use bis, tris, tetra keys. If two complex ligands are there, we have to use bis. If three complex ligands are there, tris. If four such type of complex ligands are there, tetra keys, like that. So see one example here. What is that? Now nickel GLY taken twice, and of course that glycinate means having which charge? Minus 1 charge. As two glycinate ions are here, oxidation number of nickel X plus 2 into minus 1 equal to 0, X equal to plus 2. Now what is its name? As it is a complex ligand, we have to use bis glycinato, bliss bisglycinato, nickel. Oxidation number is how much? 2. So its name is bisglycinato nickel 2. And also sometimes another ligand, but what is that? Ethylene diamine. So if ethylene diamine is given, how to name that? See here. For example, CO En taken thrice is given means, actually ethylene diamine IUPAC name is what? Ethane 1 comma 2 diamine. So we have to name like that only. As these are in 3 in number, this can be called as tris ethane 1 comma 2 diamine. And this is which one? Cobalt. And of course its oxidation number 0. So cobalt 0. So like that, if complex ligands are present, we have to name that number. We have to indicate the number of such ligands as bis, tris, tetra keys, like this. Okay, then sometimes here another one critical example I give. What is that here? Same metal present as a counter ion and also as a central atom. So example here, Fe4 Fe, and here what we can take here, any example, Cn taken 6. Now what is this name means here? First we have to give its name as which one? Iron, and we have to write its oxidation number. So now let us consider that oxidation number 3, iron 3. Now this name is we have to pronounce as hexacyano. Now this can be called as which one? Ferrate, and oxidation number 3. So now this name is iron 3 hexacyano ferrate, which one? 3 we can get. So like that sometimes same central, that means same element present as a counter atom, and also that which one central metal ion. Okay, then now let us see the nomenclature of two coordination compounds present with one another. So one example here, what is that? AgNH3 taken twice and AgCN taken twice. To name this type of complex compounds, how we have to go for that naming? See here, this NH3 is having zero oxidation state. So now oxidation state of this silver atom is zero, and here AgCN taken twice. We know that cyanide is having -1 charge. So now this silver will get which one? +2 charge. But we have to share that +2 to each and every silver. That means this silver also having +1 oxidation state. This silver also having +1 oxidation state. That is one thing we have to remember. Another thing, this should be considered as a counter atom, and this should be considered as which one? Coordination pair. It is as ionization pair. This we have to feel like a coordination pair. As this coordination pair containing one ionization pair, now this become which one? Already we have given this is having +1 charge. That means this should be taken as which one? Anionic complex. So now what is this name? First here, diamine silver, and its oxidation number 1, and here dicyano, but this should be pronounced as argentate, oxidation number again 1. So like this, diamine silver 1, dicyano argentate 1, we have to give the name. Another example I will give for such type. What is that here? CONH3 taken 6, and here again we can write which one? Okay, write chromium now, no problem. CrCN taken 6. Here ammonia is neutral ligand, so this cobalt get oxidation number 0. But chromium oxidation number here, let it be the X, 6 cyanide ions are there. Means this chromium will get to +6 oxidation number. Now share it to 2 central metal ions. Now this cobalt will get to +3 charge. Chromium also get +3 charge. Now what is its name now? As 6 amines are there, hexaamine, and this is cobalt in bracket Roman number 3. Then we have to name this one. This we have to fill as anionic complex. So now this can be named as hexacyano. Let it be that let it be the name which one? Chromate, and oxidation number 3. So like that here it is named as hexaamine cobalt 3, hexacyanochromate 3. So like that. And then let us go for which one? Some bridge ligand complexes or bridge complexes. That means in some cases bridge ligands are present. They connect which one? Two central metal ions in the coordination pair only. So now let us see such type of examples here. What is such type of example? Consider here En taken twice, CONH2, and here OH, here which one again? COEN taken twice, SO4 taken twice. So this is the example for bridge complex compound. To name such type of compound, how to we have to follow the order. See here, now here this is complex ligand, so we have to name it as bis ethane 1 comma 2 diamine, ethane 1 comma 2 diamine, cobalt, and then here this we have to name. But while naming the bridge ligands, what we have to give its name here? Mu, and this is named as amido, mu amido. And here which one? Hydroxo, so it is named as comma mu hydroxo. And again we have to name this one again, bis ethane 1 comma 2 diamine cobalt. Now we have to write the oxidation number also. How to split the oxidation number? Let us see here. NH2 is having -1, OH is having -1, SO4, each SO4 having -2. So total oxidation number, how much we can get means total plus 6, because -1, 2 twos are -4. -6 when we send to right side, total oxidation number plus 6. But we have to share that plus 6 to two central atoms. That means each cobalt will get plus 3. So now we have to write that oxidation number here, cobalt 3. Here also we have to write which one? Cobalt 3. And outside the coordination sphere, what is ionization sphere? Sulfate. So we have to name it as a sulfate. So we have to give the nomenclature for bridge complexes like this. And finally one thing is there, sometimes same component present as the bridge ligand and also as a terminal ligand. That means what is that type of complex? Let us see here. What is that? Iron complex will let us consider here. Iron complex compound. What is that iron complex compound? See here. For example, CO is the ligand here. CO taken thrice, iron. Here CO, and here also iron, CO taken thrice. So now how to name this compound here? First, these acting as a bridge ligand, but three ligands are there. So we have to name it as mu triscarbonyl, triscarbonyl or tricarbonyl also you can say, okay, mu tricarbonyl. And here 3 plus 3 6 carbonyls are there, so hexacarbonyl. Two iron atoms are there, so di-iron oxidation number is 0. So like this we have to give the naming for which one? Different type of complex compounds. So this is regarding nomenclature of complex compounds. Okay, in our next video let us see Werner's theory and its applications. Okay, bye.